So I've got an interesting problem for you and me today. If you remember a few years ago in GCSE Maths, there was the tricky 3 overlapping circles problem that stumped a lot of people. Well, this is essentially level 3 of that. That was level 2, this is level 3. We're going to give it a go today, so let's get straight into it. Shown is a circle of radius r and centre O in which AD is a diameter. There's a diameter. The points B and C lie on the circle such that OB and OC are circles. Sorry, that should say arcs of radius r with centres A and D respectively. Okay, so since this says arcs, what we're going to do, we are going to draw the whole circle. So let's see how well this is going to go. Well, that's not bad. Okay, and there we go. So we've drawn the full circle, and you can see it literally just looks like a tilted version of the 3 overlapping circles problem. So if you remember how to solve that, if you don't know, I recommend you search the problem up online, give it a go. We're going to be drawing in our radii. So all of these lengths here that I'm drawing in red are all equal to each other. Okay, there we go. So we've got some triangles there. So what we're going to do, we're going to try and work out the area of the triangle. So what formula should we use? Well, half base times height. We know that this is r, this is r, this is r, but we don't know the height, so it might be a bit longer, more long-winded to do it that way. So I think we are going to be using half AB sine C, okay? So what is A and B? Well, they're all going to be r. It doesn't matter what direction we go from, it's all going to be r. So it's going to be half times r, and C. What is going to be the C value? Well, since all the side lengths are, we know that it must be an equilateral triangle, which means that all of these angles must be 60 degrees. So we can say that this is going to be sine 60, okay? We can start simplifying this a bit. Half, that's just going to be r squared. What is sine 60? Exact trig values, that's going to be root 3 over 2. And then we can combine these fractions, so we end up with root 3 over 4 times r squared, which is equal to r squared root 3 over 4, like that. Now that we've got the area of that triangle, I'm going to note it down, and we are going to work out the next bit. If you've got any guesses, write down below in the comments. But we are going to be working out the area of the sector, which we're going to be doing in blue, okay? This sector right here, like that. So the area of a sector is going to be equal to theta over 360 times pi r squared, okay? Because pi r squared is the area of the whole circle. Theta over 360, you're taking a proportion out of 360 degrees. And that's exactly what we're doing. So what is this angle here? That's going to be 60 degrees, isn't it? So it's going to be 60 over 360 multiplied by pi r squared. What is 60 over 360? That's just simplifies to 1/6 times pi r squared, right? But what we're going to do, and this will help in the long run, is going to put the pi r squared on the top. So we end up with pi r squared over 6, like so. So the area of the sector equals pi r squared over 6. Hope you can see that. The lighting's a bit dodgy, but I'm trying my best. Now, we've got these two measurements. We can work out the area of the segment, which we're going to be doing in green. You can see I've highlighted right there. So the area of the segment is going to be equal to the sector minus the triangle, okay? The area of the sector, pi r squared over 6, and the area of the triangle is r squared root 3 over 4. Now we're subtracting fractions, we've got to find a common denominator, so it's going to be 12, right? we're going to write it all as one fraction. You don't have to do it this way if you don't want to, but I personally like to do it this way. So it's going to be 2 lots of pi r squared, subtract 3 lots of r squared root 3. And then if we simplify this, we get 2 pi r squared minus 3r squared root 3 over 12, okay? Let's write that over here. The segment equals 2 pi r squared minus 3r squared root 3 all over 12, okay? Now we are actually nearly done with this problem. We're going to do the finishing bits in a black pen. So, to work out the area of the shaded region in red, we have to work out, well, this is one method I'm going to be doing. There's another method. If you know, let us know down in the comments below. But we're going to be taking the whole area of this semicircle and subtracting these regions here. These 2 regions here. Okay? So what is the area of a semicircle? Let's do SE. That's going to be half pi r squared, right? I'm going to write that as pi r squared over 2 for reasons you will see in a moment. Okay? So first of all, let's work out the area of these 2 regions here. Okay? Okay, so the area of the shaded region, let's do SA. It's going to be 2 lots of, because there's 2 of them. And then we're going to take the area of the triangle, which is r squared root 3 over 4 plus 2 lots of this behemoth of an expression. Let's just write it down quickly, like so, like that. Okay, and we can start simplifying it. So we're going to work from the inside outwards. That becomes 1, that becomes a 6 because they cancel out, and we end up with 2 pi r squared minus 3r squared root 3 over 6. And then we've got to work out the common denominator over here, which is going to be 12. And that's going to be 3r squared root 3, because to get from 4 to 12 you multiply by 3, and to get from 6 to 12 you multiply by 2, so it's going to end up 4 pi r squared minus, don't forget the second term, multiply by 2, 6r squared root 3, like so. And then this just cancelled out, like so. So we end up with like something looking like this. But wait, look, we've got some like terms, don't we? So we can actually rewrite this as 4 pi r squared. 3r squared root 3 minus 6r squared root 3 is minus 3r squared root 3 all over 6. Alright? Now, we've got the area of the shaded region. Now we need to work out the area of that shaded region. I should have made that a bit clearer. We've got the area of these 2 regions, and we need to work out the area of this shaded region here in the stripy red, okay? So, like we discussed before, it's going to be the area of the semicircle. So the area of the shaded region is going to be half pi r, sorry, we established that we're going to write it as pi r squared over 2 minus, let's do it all in brackets, and the area of the shaded, the 2 regions we did over here. So that's going to be 4 pi r squared minus 3 r squared root 3 over 6, like so. Now, this is where the problem really trips up a lot of students. What we're going to be doing is rewriting this as the same base, but we're still going to be utilizing our brackets. Now this is going to be the most important part of this procedure, because I've made this mistake, a friend of mine has made this mistake. It is a very common mistake to make, and we're going to rewrite it all over the same denominator, like so. So we're going to end up with 3 pi r squared minus, and use your brackets here, 4 pi r squared minus 3 r squared root 3. Okay, we're going to take it up here, and we're going to get rid of those brackets. So we're going to end up with 3 pi r squared minus, you're subtracting a positive, so it's going to be subtract, and here we're subtracting a negative, so we're going to be adding it. So you're going to end up with plus 3r squared root 3 all over 6. Now you can see we've got some like terms, so we're going to end up with minus pi r squared plus 3r squared root 3 over 6. Okay, and then we can move this 6. I'm going to do two things in one just to make it a bit, because we're running out of room. We can move the 6 to the front, so we end up with 1 6 times, so 1 over 6, and then times, and also we're going to be swapping these terms around just so we can get as close to the expression that they want it in. So 3r squared root 3 minus pi r squared. Okay. Now we're going to do this last bit in red. You can see they've also got a factor of r squared taken out of the expression, so we're going to do exactly that. We already got 1 6 taken out as a factor, but we do have an r squared in both of the terms, so we can take an r squared out. Like so. We take an r squared out as a factor, and we're left with 3 root 3 minus pi, and would you look at that, that is the same way that they've written the expression in the question, which means that we have shown it with a lot of steps and a lot of deliberation. It's a really nice problem if you know how to do it. Please don't trip yourself up when subtracting these. I've done that far too many times. I had to go to sleep and have a think about that to get it right. It's really good if you enjoyed the 3 overlapping circles problem. I'm sure lots of you did if you got it right. If you want to see more interesting cool maths problems walked through, please subscribe, like the video if you enjoyed it, comment below if you've got suggestions or if you have any feedback, share the video with friends, family, acquaintances, teachers and educators. Just one more thing before I let you go, is another way you could have done this, taken the 2 areas of the segments, and you could have just taken the area of that sector there, that entire sector, and then subtracted those 2 from it to get that shaded region. But I feel like when I was doing this problem I noticed the semicircle first, so it's honestly up to you, but whatever you did, I hope you enjoyed this. Do all the things I've previously mentioned, all that good stuff. I hope to see you in the next video or in a previous video, whenever. Thanks for watching. Goodbye.